Hi everyone, we're going through Extension 1 2023, question 14C. There's two parts to this question, part 1 and part 2. One of the things to make a really good point of is that the examiners have actually given a hint in both parts, which make it really obvious what approach they want you to take. So the hint, by the way, I've just got a little diagram down the bottom to show that if you have two vectors, AB, with the coordinates of the first one, and they're perpendicular, you swap them and make them negative. Negative reciprocal if they're perpendicular. So that's a hint to use that. So back up to the diagram. I didn't give you the diagram. They know that OA is A1, A2, and OB is B1, B2. I've drawn OA longer so you can show with the area of a triangle that it's the perpendicular height. Okay, so the area, that's what you want. The area of the triangle is a half of the base times the perpendicular height, which is what's going on here. And the base is the length, the magnitude of OA times the perpendicular height. So what's the perpendicular height? Well, that's the length. Using the hint is we want to write straight away this vector here that's perpendicular to it is minus A2, A1. So you swap them around and put a minus. So that perpendicular height is that, which is the projection of V onto O, or this vector that's perpendicular to OA. So what is that length? Okay, we need an expression for that length. We know that the dot product of UV, I've called this one U and this one V, is the length of U times the length of V times cos theta. And because that's theta in between it, you can see that cos theta is H over the magnitude of V, which is what we have right here. And then you can make H a subject of that by putting the dot product back in. And H ends up being U dot V over the length of U. That means in the area, the triangle is a half times the length of the base times the perpendicular height becomes like this. Now, what's the length of OA? Now, the length of OA, and it was also mentioned in the hint, actually has the same magnitude. This length has the same length as that. So the length of OA is actually the length of U. So you can actually replace OA with the length of U, and then they cancel, and you get, it's a half, the dot product. And the dot product of these two is, of course, just that times that and that times that. So it actually comes out really nicely. You need the absolute value lines because they might have been the other way around. It might have had that U was going downwards and it actually became negative. Okay, so that was the first part. Oh, by the way, a lot of people do learn the dot product, the projection formula like this, which if you take the length of U out, that's the unit vector, so that has a length of 1. So this is actually the length of that projection, which is quicker if you've practiced this enough. But it is always best to know how to get it from first principles. Okay, on to the second question, which is the last question on the paper, which is always supposed to be the most challenging. This is reasonably accessible. So we've got that picture there. So we're trying to find the area of this triangle that makes a maximum. So, not using what we've been given. So that was the hint here, to make sure you use what you've given. So you've got these two circles, which has got double the radius on this one, or double the angle, I should say, on this one. And you want to know what this area is as a maximum. You want to know what does T equal for this to be a maximum. Okay, so using the hint, or in other words, using part 1, you actually want to know what these two are as coordinates for the vectors, so we can actually use the hint. Okay, we want to use that hint right here, the part 1. And it actually tells you also that tells you that OP is OA plus IP, so here's OP. So OI times plus IP. So they're giving you that hint, and they tell you that this one as well. So they know that OQ is that plus that. That's basically saying, get the coordinates for the vector. Okay, so the vector, we'll go this one first, OP. OP is OI plus IP, so R0 plus R cos t plus R sin t, just using the triangle here, breaking it up into horizontal and vertical components. So you get these coordinates pretty quickly. And the same thing going this way, that plus that, which is here, and you add them together, you get these coordinates. So you're up to this stage, you've got coordinates for the vectors, or column notation form for the vectors, OQ and OP. So then you have to use the hint, well, not the hint, the part 1 that was given. So it's a half that, or A1 B2 times minus A1 A2 B1. So you go this times this, using what A1 and B2 is, and this times this, using what A2 is and B1 is. Okay, so, and they're in the absolute values because that is exactly the part 1 section. Now we expand these things, do a bit of factorising, take out the r as a common factor here, and then a little r, and then small r and capital R as a factor as well. So you end up with a factor of r, which goes right out the front because this is just a scalar, just a number, times this is the thing that varies. So collect like terms. Oh, and you notice that you do get a sine 2t cos t minus sine t cos 2t, which is, using the sine A minus B rule, sine 2t. So that comes in there as sine t, so you end up with a really nice expression. You get sine 2t and plus 2 sine t. And this thing, this is for the area, and this is actually an expression out the front, so this is just a scalar multiplier. This is the thing that varies. So we're looking at, in the question, what value of t gives a maximum area. So now we're looking at this thing, because this thing's fixed. So when does this thing here become a maximum? Now, there's lots of ways you could do this. I actually drew this graph because I didn't think drawing that plus that is too hard, because you can draw them separately very nicely, the little black one, the little red one, add them together, and you do get this shape. Remember, we only have to consider between, in the question, between minus pi and pi. Okay, so it's actually an odd function. The blue graph's an odd function, and it clearly has a maximum value between 0 and pi. So that's to save us a bit of time. You don't have to do a rule to show you that's a maximum. So I just want to know, when is this thing here a maximum? So because it's a maximum, it's a little bit hard to tell. I can tell it's less than pi on 2, but I don't know exactly what it is. It doesn't line up with the maximum of sine graph, by the way. Okay, so maximum, so that means you just differentiate it. Okay, it's pretty easy to differentiate. You've got a cos 2t, which use the double angle rule, swap the sine squared to 1 minus cos squared, and you end up with a quadratic in terms of cos squared pretty quickly. Technically, this is maths advanced work. So then you've got to factorise that, which you get to here. So you get two expressions, which to be a maximum equals 0. Either 2 cos t minus 1 or cos t plus 1 equaling 0. So if you take the first one here, 2 cos t minus 1 equals 0, you end up with cos t equals a half, which equals t equals pi on 3, and you go, oh, hang on, it was a little bit less than pi on 2. That's pretty good. That's actually the answer that we want. And the other one isn't trivial. The other one you get pi, which makes sense because when these things end up, when this angle, and this p ends up right over there, the angle is pi for t, of course that gives you the opposite end. It doesn't give you the maximum, it gives you the minimum, which is, it's a horizontal line. They're all on the same point, like Q, O, and P are all on the x-axis. So that gives you an area of 0 because they're collinear. So that's the minimum if it asks for the minimum, which is a bit trivial. The only other thing to realise, because you wouldn't get full marks for this at this stage, because it's not just pi on 3. There's two answers because it asks you between minus pi and pi. Now, it's the absolute values. So if you're drawing an absolute value graph, it would look like this. I'll draw it on here quickly. And this one becomes flipped over because it actually becomes an even graph. So it's that one as well, which of course is minus pi on 3. So you can justify that over here by saying that the absolute value lines means that it's, because the original one is odd, when you flip it up, it becomes even. So minus pi on 3 also gives you the maximum. So in the end, the answer is for t, to get the maximum area, is pi on 3 and minus pi on 3. Cool question.